Seidenader 3D inspection. Conventional inspection extended by a third dimension to detect particles in highly viscous products. Inspecting highly viscous products can be quite challenging, since a reliable detection of particles with common inspection methods works only for liquid products. The principle of particle inspection for liquid products. Conventional camera inspection by Seidenader solutions identifies particles in liquids by monitoring their changes in position. Stationary markings, scratches, or contamination on the outside of the container can therefore be clearly differentiated from particles inside the container. By rapidly rotating the container, its liquid contents and potential particles are set in motion. Once the rotation of the container stops, liquid and particles keep moving. Markings, scratches, and contamination on the outside, however, are no longer moving. A camera takes several images which are then compared to each other. Every object that has not changed its position is masked and subsequently deleted from the resulting image. What remains are the objects which have changed their position from one image to another, the particles. The challenge: particle inspection for highly viscous products. When inspecting highly viscous products, the described inspection method produces no results, since the contents of the container cannot be set in motion by rotation. Since there are no changes in particle position between the images, impurities inside the container cannot be differentiated from those on the outside. Introducing a new dimension of inspection technology: 3D inspection of highly viscous products. This revolutionary 3D inspection by Seidenader solutions enables the reliable detection of particles in highly viscous products such as hyaluronic acid. The conventional inspection method is extended by a third dimension. High-precision handling, the interaction of high-resolution cameras, and innovative computation methods now also enable the identification of particles in highly viscous products. In the first stage of 3D inspection, the camera takes an image. To distinguish between particles inside and outside the container, two virtual images are being generated. It is initially assumed that all particles which are visible on the real image are located outside and on the back surface of the container. A calculation is now carried out to see how the image would look like after rotating the container by a defined angle. At the next stage, it is assumed that all particles on the real camera image are located outside and on the front surface of the container. After the same defined rotation, the actual image would now look like the second generated image. At this point, the container is physically rotated by the defined angle, and a second real camera image is taken. This is compared to the two previously computed images. If a particle on the real camera image matches a particle from one of the generated images, the assumption that the particle was indeed on the outside surface of the container is correct, and the particle is masked. This process is repeated until the entire circumference of the container has been inspected. In the final image, only unmasked particles are shown, which have been identified by the process of elimination as being clearly located inside the container. Seidenader 3D inspection, the solution for particle detection in highly viscous products. Kerber, delivering the difference in pharma.